In this series, I've shown how to turn on and off LEDs for the Pico, but how about dimming them? The approach to doing that is called PWM, pulse width modulation. It's something we use a lot of, from dimming LEDs to driving motors, the angles on servos, or even stepper motors. PWM is a really useful capability, and the Raspberry Pi Pico has 16 PWM channels. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, robotics, IoT and other fun tech. Remember to subscribe and join the community. This is my 3-minute summary version of this video. If you have time, why not watch the full version? In this video, I'm going to talk about the basics of PWM with the Pico, using this to simply dim and fade an LED, fade being just animating the dimming process. There are a couple of gotchas with PWM on the Pico. They're not going to affect you when you're trying to use a single LED, as I'm going to do in this video, but in more complex cases they have. I'll explain how to avoid these. PWM is really just turning on and off the GPIO pad in a cycle, quickly. That results in us seeing the LED as dimmed, and when we change it over time, it looks like a fade effect. The portion of the cycle that is high compared to low gives us a different brightness, as you can see on this oscilloscope here. We call this portion of the cycle to signal ratio for the high to low a duty cycle. And duty cycle is an important concept because it's the way that we control PWM. We could adapt the code for flashing the LED to give us a PWM signal, change the amount of time the LED is on versus off to control the brightness. We don't have to do that though, because the Pico has 16 PWM channels we can use. These are created by 8 slicers and controlled through the hardware PWM library. I've created an example to show this by fading an LED. It's in this repo and built using the normal build process. This time we set up the Pico pads to have a PWM function. We then use that to set the brightness by setting the level on that pin. That's a value from 0 to hex FFFF. So we can see the LED fading here, both up and down in brightness. There are some gotchas when using PWM. 8 slicers have 2 channels and are mapped to specific GPIO pads. Notice that some pads share the same slicer and therefore could not be used for different PWM signals. Also, when we modify the frequency of a PWM signal, we do so at slicer level by setting the clock divider and the wrap point of the counter. By default, this was the hex FFFF, but we can make this a much lower value to increase the speed. Both channels of the slicer will share the same clock divider and the wrap point. I've done a few other videos touching on PWM before. DDD, my DIY dev droid, uses PWM to drive the speed of the motors. I did a video talking about how motor control works from the Pico for DDD. That might be a good next video to watch. If this video or any of my videos helped you out, then please do buy me a virtual coffee to say thanks, or perhaps even lunch. There's now a super thanks feature live on my channel. Just click the button underneath the video. Thank you very much for watching. If you enjoyed the video, please hit the like button. Please subscribe to my channel so you don't miss the next video. Bye bye for now.